All right, and welcome to the final tutorial for this section, tutorial number 3, where the objective is to find the inverse of a function. So let's flip over to one of our final examples here. I'm going to work this example finding the inverse here, and I'm going to show you the steps along the way. Okay, so first of all, I'm not using even the word inverse, so you need to know that this symbol means the word inverse. We're looking for the inverse of g of x. So it's a four-step process, pretty simple. The first step is just so it's easier to deal with, instead of dealing with the g of x symbol, let's just change g of x to y. I mean, it is just a fancy name for y, so let's go ahead and do that first. It's just easier to manipulate a y, I believe. So y equals 5 minus 3x divided by 2. So that's the first step. Step 2, swap x and y. Swap x and y. All right, people are going to think that that's a plus sign. It is not a plus sign. That's an and. Well, there we go. Okay, swap x and y. So we're going to take wherever it says x, we're going to put in a y. Wherever it says y, we're going to put in an x. So x now equals 5 minus 3y divided by 2. Actually, after step 2, you have the inverse. This blue equation is an equation of the inverse. It's just not the equation that we want because we typically solve for y. And that's what step 3 is going to be. Solve for y. So since y is up here, we've got some numbers to get rid of. We need to get rid of the -3 and the 5 and the 2. And the one that's farthest away is typically the first one to go. So I'm going to multiply both sides by 2 to unlock that 2 out of the denominator. So now I've got 2x is equal to 5 minus 3y. The next number I'm going to get rid of is the 5. So subtract 5. They're not really like terms over here, so I'll put them side by side. 2x minus 5 is equal to -3y. And final step, let's divide by -3. When we divide every term we see. If you don't mind, I'm going to put the y over here. Y is going to be equal to, this is -2/3 x, and then this is a positive term plus 5/3. Now, this is a fine way of writing it, especially if you're going to end up graphing this line so you can see the y-intercept and the slope. If you'd rather put them both together as one fraction since they have the same denominators, we could do that. That would be acceptable as well. And then our final step, once we started with fancy language, so we should end with fancy language. I don't want to end with the y. Let's change y back, and this time it's going to be our fancy little inverse symbol. So don't leave it with the y, put it with your inverse symbol. G inverse is equal to, and it's either one of these is, again, -2/3 x plus 5/3, or -2x plus 5 quantity thirds. That's fine. Either one of those would be acceptable. So it's a simple four-step. It's not really even 4 steps because the first 2 steps are just changing the syntax, what things look like. Step 2 is the meat. You just put in the x and the y, and then 3 is where the algebra comes in. You're just solving for the new y. Let's look at a trickier type of problem. This will be the end here. So we've got m of x. Here's Marsh of x. Here's our big guy. All right. And we're going to be looking for the inverse. Okay. So I'm ultimately wanting to know what's the inverse of Marsh of x here. Okay, so we're going to do our simple steps. So let's change the m of x to y. So we got y equals 2x plus 1 divided by x minus 3. Step 2 says swap the x and the y. So where I see a y, I'll put an x, and where I see an x, I'll put a y. Okay, the trouble with this one, obviously now we're solving for y because that's what step 3 is. The trouble with this one is we actually have 2 different terms that have the y. So I'm going to have to figure out how to deal with that. First thing I'm going to deal with, though, is I don't like this denominator, so I'm going to multiply both sides by the y minus 3. That's what I'm going to do first, just so I can cancel out that denominator. I'll go ahead and distribute here. I'll get xy minus 3x is equal to 2y plus 1. Okay, so this situation we're going to be dealt with, or we're going to have to deal with a few times this year, where we have multiple terms that have the variable that we're looking for. In this case, we have an xy term and we have a 2y term. So whenever we see something like this is what we're going to do to attack that. We're going to put the two terms that have the variable that I want on the same side and everything else on the opposite side. So since the xy term is sitting right here, I'm going to go ahead and subtract the 2y term to it. So I'm going to have xy minus 2y. And at the same time, I don't really need this term because it does not have a y in it. So I'm going to add 3x to both sides. And so I'm going to put it as 3x plus 1 because usually we like the variable term to come first. So all I did was I put this term, the 2y, over here as negative 2y, and at the same time put this term over here as a positive 3x. We wanted both terms with our variable to be on the same side because now it's a common factor. Y appears in both of our terms, so I should be able to factor it out from both of those terms. If I factor out a y from each of these terms, I'm left with an x and a negative 2, and that's all equal to 3x plus 1. And now I only see y once, and I see that something is multiplied to it. So if I just divide by x minus 2, y should be all by itself. So y is equal to 3x plus 1 divided by x minus 2. Don't forget your fourth step. Don't go all that way and not use your fancy language. We ultimately are looking for an inverse, so I want the fancy symbol for inverse m to the negative 1 of x. That's not really a negative 1 exponent, it's just a symbol for inverse, and that is equal to 3x plus 1 divided by x minus 2. And that's our inverse. So the tricky part of this one is if you have multiple terms that have the variable that you're looking for, put those multiple terms on the same side and factor out the common variable, and then divide away whatever's left. And then you'll have your answer. So here's our inverse, and that's the end of this tutorial. Have some fun with that, and I'll see you in class to practice. Bye-bye.